In 1103, we're going to have a look at using where we use Z-scores and how to make the most of this type of statistical measure that we can calculate. You saw back in 1102 that the Z-score can be found using a formula, but I hope you realised more than just performing that calculation for the Z-score, and realise things like a positive Z-score means the result is above the mean. A negative Z-score is below the mean. A Z-score over 3, positive 3, would be very unusual because you're moving into that category or under the normal curve where there's really a very small percentage of scores are going to lie. So knowing that about Z-scores, we could say that if you had a Z-score of 2 in maths and a Z-score of 2 in English, then you're performing at about the same place in both subjects. Now, it's really an important indicator in terms of the HSC. There will be the average mark, there will be the top mark, there'll be a very small percentage of students who get a result greater than 3 standard deviations above the mean. There'll be 68% of the students who will get a result in the range, the mean minus 1 standard deviation plus 1 standard deviation. So 68% of students get a Z-score between -1 and +1. So back to how do we use the Z-scores now? They're much more useful. It's a much more useful statistic when it comes to comparing results. And you'll see here just another name to be aware of. Z-scores are sometimes referred to as standardized scores because we have a common standard, and the standard is the average and how far above or how far below the average the result actually was. So it doesn't matter so much what the average is. So in English, the average is 70, and in maths, the average is 80. It doesn't matter that those two values are now different. What does matter is how far above the average was your result. And it also doesn't matter what the standard deviations are from maths to English. It's just a measure of how far above everyone else you actually are. So if we look at this example, just be aware that sometimes you'll may come across the term standardized score. Let's have a look at this example. Ashley's marks for math, science and history, as well as the mean and standard deviations of her class marks for each subject, are given in the table. So you can see that Ashley's mark was different for each subject. The actual mean is different for each subject, and the standard deviations are different. Sorts of things we'd know we can, without doing any calculation. History doesn't have a very big standard deviation, so the scores were more tightly packed around the mean. And a bigger standard deviation was found in the maths results, so they were quite spread out. Ashley's mark is above average in maths, it's above average in science, but it's below average in history. We can see those results doing absolutely no calculations. If we want to see which one of these, maths or science, which are both above the average, if we want to see which one of those subjects she actually did best in, then we need her Z-score for each subject. We can see that she's not done so well in history because her result's below average. So we're already anticipating a negative Z-score there. To calculate the Z-score, just use the formula. So you can see there, I've taken the formula, her score minus the average over the standard deviation. So for maths, her score was 80. The average was 75, or the mean, all over 16. And so she gets a Z-score of 0.3125. We expect a positive Z-score because we can see that her result is above the mean. In science, she's also above the mean. And you might look at these two results and say, oh, well, look, she did clearly she did better in maths because she got an 80 compared to she only got a 60. But what we're not considering with that 80 is, how did everybody else go? We don't know that. We don't have that information. But so all we can do is compare her result to the average and take into consideration the standard deviation. How spread out were these scores? So the 60 is compared to 54, but with a smaller standard deviation, and 60 subtract 54 divided by 12 is 0.5. So on a scale 0.3, 0.5, you can see here she's got a higher Z-score in science. In history, her score was 70, she's below the mean, minus 78. We're expecting a negative score, and if you do 70, subtract something bigger, you're going to get a negative number, divide it by 10, and you get 0.8. Negative 0.8. So we're expecting that, and we know that she's below average in history. Part B asks, in which subject did she perform best? She performed best in science. And justify your answer. Her science result had the highest Z-score. And so you're writing a sentence answer to that question. So hopefully you can see from that little example the importance of actually getting appropriate statistical calculations like Z-scores before you start comparing results, because initially it looked like she had done much, much better in maths, but maybe what we don't know is the maths exam was easy-ish and people were getting even much better results than 80. Whereas here in science, the average was 54, quite low, and getting a result of 60 actually placed her a little bit further ahead of the other students. So that information is really important. And you can apply that to your subjects here at school. You don't necessarily compare your raw marks. It's not the raw mark. It is actually, your raw mark is not a best indication of how you're going. You really want to know what your Z-score is, because ultimately you are compared with everybody else. And in the HSC, that will be everybody else in the state that does your subject. You need to know what your Z-score is, so you can see how you're possibly going to fit compared to everyone else.